Today we are going to discuss about the memory glands. Each breastina hemisphere constriction of variable size anterior to the posterior majors and serratus anterior muscles, which is present on the chest, and attached to them by a layer of fascia, thick sheet, so composed of the dense irregular connective tissues. Each breast has one pigmented projection, the nipple, that has a series of closely spaced opening of duct called the lactiferous duct. Lactiferous means milk duct, where milk emerges. The circular pigmented area of the skin surrounding the nipple is called the areola. Small, small space. It appears rough because it contains modified epithelium or glands. Strings of connective tissues called the substantial ligament of the breast, mucous ligament we call it, run between the skin and the fascia and support the breast. These ligaments become looser with the age or with the excess strain that can occur in long-term jogging or highly impact aerobics. We are wearing a supportive bra can slow this process and helps maintain the strength of the suspensory ligament. Within each breast is a memory gland, a modified suberophorus sweats gland, and that produces milk. A memory gland of 15 to 20 lobes or compartment separated by a variable amount of adipose tissue. So this is the anatomical structure and few glands we will discuss. This is the female breast. In each lobe are several smaller compartments called the lobules, composed of the grape-like cluster of milk secretion glands, termed alveoli, small cavities, embedded in the connective tissue. Contraction of myoepithelial cells surrounding the alveolar helps propel milk towards the nipple. When milk is being produced, it passes from the alveoli into a series of secondary tubules and then into the mammary duct. Near the nipple, the mammary duct exposed to form sinuses called lactiferous sinuses, where some milk may be stored before draining into the lactiferous duct. Each lactiferous duct typically carries milk from one of the lobes to the exterior. The function of mammary glands are synthesis, secretion, and ejection of milk. These functions called the lactation are associated with the pregnancy and childbirth. Milk production is stimulated largely by the hormone prolactin from the anterior pituitary, with contribution from the progesterone and estrogen hormones. The ejection of milk is stimulated by oxytocin, which is released from the posterior lobe in response to the sucking of the infant on mother's nipple. We call it suckling. The function of mammary glands are synthesis, secretion, and ejection of milk. These functions called the lactation are associated with the pregnancy and childbirth. Milk production is simultaneously largely by the hormone prolactin from the anterior pituitary with contraction from the progesterone and estrogen. The ejection of milk addiction of milk is stimulated by oxytocin, which is released from the posterior pituitary in response to the sucking of infants or mothers' nipple suckling. Hormones regulation of the female reproductive cycle, gonadotropin, release hormones secreted by the hypothalamus, control the ovarian and uterine cycle. Gonadotropic releasing hormone stimulate the release of follicle stimulating hormones FSH and luteinizing hormone LH from the anterior pituitary. FSH initiates follicular growth with luteinizing stimulates further development of the ovarian follicle. In addition, both FSH and LH stimulate the ovarian follicle to secrete estrogen. LH stimulates the theca cell of the developing follicles, produce androgen. Under the influence of FSH, follicle stimulating hormone, the androgens are taken up by the granulose cells of the follicles and then converted into estrogen. In this way, estrogen is formed. At mid-cycle, luteinizing hormone trigger ovulation, means release the ovum from the ovary, and then promotes formation of the corpus luteum, the reason for the name luteinizing hormone. Stimulated by the LH, the corpus luteum produces and secretes estrogen, progesterone, relaxin, and inhibin. Four hormones are produced from the corpus luteum. At least six different estrogens have been isolated from the plasma of human female, but only three are present in significant quantity: beta estradiol, estrone, and estrol. So we were discussing about how these hormones are produced, and the, there are three hormones present in human female, that is beta estradiol, estrone, and estrol. In a non-pregnant woman, the most abundant estrogen is estradiol, which is synthesized from the cholesterol in the ovaries. Estrogen secretion by the ovarian follicles has several important functions. Estrogen supports the development and maintenance of the female reproductive structure. Secondary sex characteristic in the breast. The secondary sex characteristic includes distribution of the adipose tissue in the breast, abdomen, moles, pubic, and hips, voice pitch, a broad pelvis. and a pattern of hair growth on the head and body. So these characteristics are produced by the estrogen. Estrogen increases protein anabolism, increasing the building of strong bones. And this is the reason after the menopause, when there is a deficiency of release of estrogen, there are much chances of osteoporosis in such females who are at the age of menopause. In this regard, estrogen are synergistic with the human growth hormone. Estrogen lower blood cholesterol level, which is probably the reason that women under age 50 have a much lower risk of coronary artery disease than do men of comparable age. Moderate level of estrogen in the blood inhibit both the release of the gonadotropic releasing hormone by the hypothalamus and secretion of luteinizing hormone and follicle stimulating hormone by the anterior pituitary. Progesterone secretion secreted by cells of corpus luteum cooperate with estrogen to prepare and maintain the endometrium for implantation of the fertilized ovum. Endometrium is an inner layer of the uterus and to prepare the mammary gland for milk secretion. High level of progesterone also inhibit secretion of gonadotropic hormone and luteinizing hormone. A small quantity of relaxin produced by the corpus luteum during each monthly cycle relaxes the uterine by inhibiting contraction of the mammary. Presumably, implantation of the fertilizer ovum occur more rapidly in a quiet uterus. During pregnancy, the placenta produces much more relaxin and it continues to relax uterine smoothnesses. At the end of pregnancy, relaxin also increase the flexibility of the pubic symphysis and may help dilate the uterine surface, both of which ease delivery of the baby. Inulin is secreted by granulosa cells of the growing follicles and by corpus luteum after ovulation. It inhibits secretion of the follicle stimulating hormone and a lesser extent luteinizing hormone. Phase of the female reproductive cycle. The duration of the female reproductive cycle typically ranges from 24 to 35 days. For this discussion, we assume the duration of 28 days and divide it into four phases. The menstrual phase, 5 days, the pre-ovulatory phase, ovulation, and the post-ovulation phase, menstrual phase. The menstrual phase, also called the menstruation or menses, month, lasts for ordinary, regular, roughly the first 5 days of the cycle. By convection, the first day of menstruation is day one of the new cycle. Even in the ovaries, under the influence of follicular stimulating hormones, several primordial follicles develop into the primary follicles and then into secondary follicles. This development process may take several months to occur. Therefore, a follicle that begins to develop at the beginning of a particular menstrual cycle may not reach maturity and ovulate until several menstrual cycles later. Events in the uterus. Mature flow from the uterus consists of 50 to 150 ml of the blood tissue fluid, mucus and epithelial cells shed from the endometrium. This discharge occurs because the declining level of the progesterone and estrogen stimulates release of prostaglandin that causes the uterine spiral arteries to contract. constrict. As a result, the cells that supply become oxygen deprived and start to die. Eventually, the entire extractive function analysis log of is separated from the endometrium. At this time, the endometrium is very thin, about 2 to 5 mm, because only the extractive bacillus remains. The second layer, the menstrual flow, traces from the uterine cavity through the cervix and vagina to the exterior. Pre-ovulatory phase before the ovulation. The pre-ovulatory phase is the time between the end of the menstruation and ovulation. The pre-ovulatory phase of cycle is more variable in length than the other phases and account for most of the differences in length of the cycle. It lasts from days 6 to 13 in 28 days. Even in the ovaries, some of the secondary follicles in the ovaries begin to secrete estrogen and inhibin by about day 6. A single secondary follicle in one of the two ovaries has outgrown all the others to become the dominant follicle. Estrogen and inhibin secreted by the dominant follicular decrease the secretion of FSH, follicular stimulating hormone, which causes other less well-developed follicle to stop growing and undergo atresia, which shrinkage. Fraternal non-identifiable twin or triplets result when two or three secondary follicles become co-dominant and later are ovulated and fertilized at about the same time. Normally, the one dominant secondary follicle are the mature graphic follicles which continue to enter until it is more than 20 mm in diameter and ready for ovulation. These follicles form a blister-like bulge due to the swelling venom on the process, swelling antrum on the surface of the ovary. With reference to the with reference to the ovarian cycle, the menstrual pre-ovarian phase together are termed the follicular phase, because ovarian follicles are growing and developing. Even in the uterus, estrogen liberated into the blood by growing ovarian follicles stimulate the repair of the endometrium cells. All the statin bacillus undergoes mitosis and produces a new statin functionalis at the endometrium. Thickness thickens a short straight endometrium gland develop and the arterioles coil and lengthen as they penetrate the statin functionalis. The thickness of the endometrium approximately doubles to about 4 to 10 mm with release to the uterine cycle. The pre-ovulatory phase is also termed proliferative phase because the endometrium is proliferating. Evolution. Ovulation, the rupture of the mature graphic follicle and the release of the secondary oocytes in the pelvic cavity usually occur on the day 14 in a 28-day cycle. During ovulation, the secondary oocytes remain surrounded by its donor, pellicida, and corona radiata. The high level of the estrogen during the last part of the pre-ovulation phase exerts a positive feedback effect on the cells that secrete luteinizing hormone and gonadotropic releasing hormone and causes ovulation as follows. A high concentration of estrogen stimulates more frequently release of gonadotropic hormone from the hypothalamus. It also directly stimulates gonadotropic hormone in the anterior pituitary to secrete luteinizing hormone. Gonadotropic hormone promotes the release of the FSH follicular stimulating hormone and additionally LH by the anterior pituitary. LH causes a rupture of the mature graphene follicle and expulsion of the secondary oocytes about 3 hours, about 9 hours after the peak of LH surge. The ovulation oocytes and its corona radiata cells are usually shift into the uterine tube. From time to time, an oocyte is moved into the pelvis cavity where it later disintegrated. A small amount of the blood that sometimes leak into the pelvic cavity from the ruptured follicle can cause pain known as the uterine burst pain in middle at the time of ovulation. And over-the-counter home tests that detect a rising level of LHS can be used to predict ovulation a day in advance. This is all about today. We will see you tomorrow again for the lecture. Thank you very much.